So we're working with section 8.7 today, modeling with exponential and power functions, and you should have all the notes written down. And we're going to start, we're looking off page 509. We're using the examples in order. So the first thing that we're doing is writing an exponential function. And remember, an exponential function looks like this. Okay, we have our base, or we have our coefficient a, we have our base b, and then it's raised to the x value. And they give us the points 1, 6, and 324. And they want us to write this function passing through those values. So the first thing that we're going to do is sub these in separately. So we have 6 equals ab to the 1, and we have 24 equals ab to the third. Now at this point we're going to kind of use like a substitution method like we would do back in a system, because that's truly what we have. We have a system here, and we're going to get a by itself. So b to the first would be the easiest here. So I'm just going to convert this. I would have to divide him over, so it would be 6 over b to the first equals a, or just b there, okay? And then what I'm going to do is I'm going to take this guy and I'm going to sub him in right here. I'm going to replace his a with what I just solved for. So I have 24 equals 6 over b, remember that's the same as b to the first, times b cubed. Now if we think about power rules here and how we multiply fractions, we can cross cancel. We can think of this guy as over 1, and we can cross cancel here. There's 3 on top and 1 on the bottom, so that leaves me with 2 up top. So 24 equals 6b squared. And then I want to solve for b, so I'm going to divide by 6. We know if I take the square root, b equals 2. Not plus or minus 2 here. We've got to take the positive square root because my base back here of your exponential function has to be positive, okay? It has to be positive. And we learned that back in 8.1 and 8.2. So now to find a, I'm going to sub that back up here. So we have 6 over, we know what b is now, 2 to the first, which would just be 2 equals a, so a equals 3. And now I can write my next exponential function using this form right here. Y equals 3 times 2 to the x. Remember, I couldn't write it like it was here because if they were touching, it would look like 32x. So I have to show that multiplication when I'm using values. Okay, so I subbed the values in. I solved for a, subbed it into the other one so that I could solve for b, found a, and then rewrote. All right. Now, if we go further into this, then we have to actually find the exponential function using a table of values. And they tell you in your notes that to do this, we have to find a linear pattern, or if we have to prove a linear pattern by using the points x natural log of y. So if we take a look at the xy table that they give us on example 2, I'm going to use all of these x's, which they call t, but we call x, except instead of using y, we're going to use natural log of y. And we're going to use our calculator to do that. So we can go into our stat, and we're going to clear that out by hitting clear enter, clear enter. I'm going to type all my regular x's in. But then when I go to do my y's, now I'm going to do the natural log of each one of those values. So natural log of 1.6, natural log of 2.7, and so on and so forth. Okay, there's my last one, natural log of 48.7. Now remember, we said if these points, x natural log of y, showed a linear pattern, then it was truly an exponential function. So we need to see this graph. We need to see if their points give a linear pattern. So you're probably going to have to turn your stat plot on. Second y equals, turn that guy on, and now hit graph. We can see this form. Now it's not, oops, I must have something else in mind. Okay, Now, it's not maybe a perfect line, but we can definitely see that it's linear, okay? It's not going to look like a parabola. It doesn't look like a curve, okay? So we do think that it's linear. So then we can use that by going to Stat, over to Calc, and saying we want it to create a linear equation for us. Okay, so we're going to copy this over here. So we have y equals 0.38 if I use hundredths place, plus 0.26, okay? But think about what we put in our xy table. Yes, we put x in, but we didn't put plain old y in. We put natural log of y in. So that's how that linear equation changes. Okay? Now I need to get y by itself. I need to get y by itself, meaning I need to get rid of this natural log. So to do that, I can write it as a power. Remember, natural log has a base of e, so I can write e to the everything on this side over y. Which is great, but remember, I want this to turn out to look something like this. I need an a as my coefficient, and I need a b as a base. So I need to split this apart. Well, if you think about it, addition, if we think about property of logarithms or property of powers, addition means multiplication. So I could split these up and say e to the 0.38x times e to the 0.26. Remember, we multiply powers by adding the exponents? Well, now we just did the opposite. We saw that the exponents were being added, so we split them apart and multiplied. Now let's clean those up. If I do e to the 0.38, I get 1.46 to the x, and e to the 0.26 is 1.29, almost. We better round that to 30. So now remember, we want it to look like this. Y equals AB to the X. So we just need to write this in the other order. Y equals, here's my A, here's my B to the X. And that's my exponential function. So yes, it was a good exponential model because I tested X natural log of Y and it was linear. Then I converted that to a linear function using natural log of y instead. Then I wrote it as a power, used my power rules to separate, and then cleaned it up. Okay, so now let's go the other way. Now let's make a power function. So a power function looks a little bit different. Power function still has your coefficient of a, but this time your x is your base and your b is your exponent. And in this particular case, they give us 2, 5, and 6, 9. So we're going to do the same things that we did earlier. We're going to sub in and have 5 equals a 2 to the b, and 9 equals a 6 to the b. And we want to still get a by itself, so I'm just going to do the first one here. 5 over 2 to the b would equal a. And I'm going to sub that in right here. So 9 equals 5 over 2 to the b times 6 to the b. Now here, we're still multiplying fractions if we think of that as over 1. But the exponents are the same now, so now we can clean up the bases. And I would have 9 equals, I can't multiply these guys because they don't have the same exponent, 5 times 3 to the b. Still trying to get that b by itself. So I'm going to divide by 5. And I have to get rid of this base 3. That means I need to take the log of both sides, log base 3. So I'll have log base 3 of 9/5 and log base 3 of 3 to the b. That cancels and leaves me with b equals, I can't do this in my calculator, So I have to use change of base. Log of 9/5 divided by log of 3. Looks like it's about 0.54. How many decimal places? Yeah, let's go 0.54. And now I'm going to sub that back in here to find my A. So I have 5 over 2 to the 0.54. Which gives me 3.44. So now I have my A and my B that I can sub into my power function. So y equals 3.44 x to the 0.54. And there's my power function. Now, to prove that a set of points is a power function, you have to plug in the points to your stat, but this time you have to do natural log of x and natural log of y. And then write your equation from there. So if we take a look at example 5, they give me this xy table, but remember I'm going to use natural log of x and natural log of y. So go to your stat. Okay, and instead of putting 0.387 in, I'm putting natural log of 0.387 and natural log of 0.723 and natural log of 1 and all the way through that natural log of 1 point, all my x's. Whoops. Okay, sorry, I thought I typed that in wrong. Now I'm going to do all my y's. Natural log of 0.241, natural log of 0.615, okay, and I have to prove that this is linear. So I'm going to go to graph, because our stat plot should still be on. And you can see it's smaller than my last one, but definitely looks like a line, okay? Doesn't look like a curve, doesn't look like a parabola, okay? So we want to go back to stat and say, since it looks linear, I want to see that linear function. What does an E mean, guys? 0. So I'm going to write that function, y equals, my m is 1.4, looks like 49, so I better go 50x plus, that had an e in it, so that means it's 0. But remember, we didn't use x and y. We use natural log of x and natural log of y. So this is natural log of y, 1.5 natural log of x plus 0. I don't actually need that, okay? And I'm trying to get y by itself. I'm trying to get y by itself. So I'm going to have to write it as a power. He has a base of e, raising it to this entire side equals y. Now this gets a little tricky here. We still know that these two are being multiplied, okay? These two are being multiplied. So it would almost be like a power to a, you know what, I could have made that so much easier. Let's go back here. Because I have a logarithm equal to a logarithm. So let's go back to here. Natural log of y equals 1.50 natural log of x. If we use property rules, this coefficient becomes the exponent. Now you have a logarithm equal to a logarithm with the same basis, so let's just drop that. And now you have your equation. Your a is 1, here's your b, or sorry, here's your x, and here's your b as your exponent. So for this one, get your log equal to a log by using your power rule or using your logarithm rules, and then you should have your power function. Now, the only other thing that they don't give you an example for here is the section that talks about on page 514, 41 through 52, where it says write y as a function of x. Okay? Write y as a function of x. Y as means y is. So I'll just pick kind of one of the harder ones, like I'll just pick like 49. So they give me natural log of y equals negative 1.5x plus 2.5. So when they say they're writing a function, write y as a function of x, that means I need to get y by itself. So in this case, I need to get rid of the logarithm. So let's write it as a power. E to the negative 1.5x plus 2.5 equals y. Yes, I have y by itself, but this is a little bit ugly. Remember, addition means multiplication. And then I can clean that up on my calculator. That almost looks like the first one we did. And I have y by itself. It looks exponential, so I'll write it the other way. Sorry, I better go over here. There you go.